Assalamu alaikum. Today we'll try to solve these questions. Draw the action and the response of the following question where each student has his own number that are shown in the below table. Of course, I just put here some anonymous one and given value for these symbols or letters. Now, a student want to test effects of BI mode. So that means here there is a proportional and integral in the equation on a special case of error, where its equation is shown as following. This error is happened, we consider it as a special case, not the normal response. A special case. Remember that. How can we create it? Just we disconnect the wires or the first element from the loop and put another device. We call it simulator sometimes. Example for this simulator is current source, and we adjust this current source or this higher communicator or whatever the simulator we can use it, and we try to adjust it to send a signal with our settings. So in this example we can say from the starting until the time A1 we put our simulator to send set point signal. Now after that, between the time of period A1 and A2 we put our set point in our simulator plus small error here D, and after that here there is mistake here, it is SB by the way, not set point. Here another example, and in another period after the A2 to until A3 we put here another set point signal plus small error. Then after period, after this period, after A3 the space return back our simulator to the set point. Now here the given set point for this student, X student, we give him a set point 2.3, and the error, first error is 2 and the second error is 7, and the period for the first limit of the period is 2.8, then 7.8, then 14, 22.09. Then he gave me a KC with this MR, manual reset, this KC and this integral. The action is direct calculation, whereas the value if you use PI mode controller are shown in the following tables. خلاص, this the tables is already given here. It should be here, this table, by the way. Now we want to solve this question. I ask us first to draw the action and the response of this question, and also here another question from the question number 1. Show here the used functions of the MV for each period. Type. I will just transfer this question here up. Oh, sorry. Transfer it here. Okay. Just continuous numbering. So here I will try to write the equations and how can we draw these equations. Now this is the equations for our MV. First, before writing the equation of MV, we need to just substitute the values for PV. Just I take the equation here of the PV that's shown here with symbols and substitute each symbol with the given number. So here SP 2.36, I put it here. Then he tell me SP plus D1, so I put 2.36 plus D1 is 2, خلاص, I put it as 2 as you seen here. For the period A 2.81, A2 that is here substituted with 7.8, and so on, and the same thing for the other equations. Then after that find the error. What's the error? BV minus set point. Why I'm choosing this action direction? Because he told me here action is direct calculation. He told me to make a direct calculation for error. That's why I'm choosing BV minus set point, not set point minus BV. Just substitute these values here on these equations and so on. I substitute the value for BV, which is become minus set point, is give me 0. So there is no error for the first period. Second period error is 2%. So the second the third period it give me also percentage. يا شباب, the period here, the error here is in percentage, by the way. The third period is 7. The error is here around 7%. Now just substitute for MV for the same periods. First period just MV equal MR. Why? Because the error is 0. So 0 multiply KC 0. K0 multiply KC over TI 0. Even multiply whatever the integrations 0. The remaining is MR. Now for the period 2.8 and 7.8, no, there is error, which is around 2. So I substitute it here in the equations. For the first equations, just put it in here, and first terms 0.64 multiply by 2, it gives me 1.28. The integration for 2, give it outside and multiply by 0.64 and divide by 1.8, it gives me 1. The integration for dt is t, as known by the operations of integration that we already talked in the calculus. So the new MV equations will become t plus 23.37. The same thing for other periods. Just substitute the values inside it. You can see that 7, substitute here, and 7, the same thing. It gives me just multiply 7 by multiply 0.64. 7 multiply 1.64 divided by 1.8 give me 3.5. And the integration for dt is t, and the mr is remaining 2.09. The final is will become 18 plus 27.57. For t greater than 40.8, the last period is written back as mr. So now we want to draw our drawings here, our the graph. As you see here, first we need to create the time. Just put here 0, then go to the fill here, down, but then sorry, series. We'll choose the columns. Step values is around let's say 0.1, and the stopping. And we know that our periods will finish after 14.8, so let's say finish at 16 minutes and see these the results. Now this one the actual time, by the way, shabab. This is the actual time. Let me explain for you how can we write our table. See, this is the table now. I need to put here my actual time in minutes, and as one column. Now the effective time in minutes, which is different than the actual time, and my BV percentage for each period. See these thick lines. It show me the above the period of it is the first period. Then after this thick line is the second period. Then after the second thick lines is the third period. Then the fourth thick line, or third thick lines show me the fourth period, which is starting from 14.81 till the infinity. Now let's go to the effective time here. Before the time 2.81 minutes, everything was normal conditions. So my BV is 2.36, which is my initial BV, and the error is 0. There is no error. And my MV equal the MR, which is 22.09%. But After that, it is starting from 2.81, which is here we consider it as zero effective time. Zero effective time. Now, at this zero effective time, we will face that BV is raised until 4.36. That means error is 2%. 2%. Now, substitute in our MR. Substitute here in our MR here, and we will see that when our time is 23.37. Why? See 0, which is the time, plus the 22 to a 23%, which is give me 23.37 percentage. From where? See, here is 22.09, but here is 23.37. From where this come? See, this is my equations. This is my first period. Look here يا شباب. T plus 23.37. This is the T, this is my 22.07, and this is the addition that we have in, because of the engagement of the proportional part here. So the contribution proportional, it's increased it from 22.09 immediately to 23.37 immediately at the zero time. Then after that, the integration actually starts. See, at the 3 minutes, which is here, we consider that its effective time 2.81, which is the 0 moment. So 3 minus the 0 moment. 0 moment is here is 2.81 in our example here. So it's 0.19, and this time we say that our error is constant still as it. So BV is still constant at this value, and the error is still constant at 2%. Now the MV we need to substitute for the effective time. I substituted here the same thing. I substitute here for 0 at the effective time, not the actual. Now put it in the equation. The equation for the new equation for the MV, it gives me 23.556, and so on. Now start substitute 3.81, which is considered as effective time 1. Then its BV is 4.36. Error still constant 2. That means I will still using the same equation. Well, the error is still existing here. So T by plus 23.37. Now continue our substitution until reach to the end, or the end limit of my interval or my period, 7.81 or interval time, which is here considered as 5. 2.8 minus 7.8 give me 5. Still the BV, the same constant error, and my substitution for the MV. Now after 7.81, my error becomes 7. Why? Because BV raised from 4.36 until 9.37. This is the new error here comes. A new constant error, by the way. So substitutions again, 4.19 give me 27. Now here it's give me here 27.57. From where? It's coming from here, from these equations. See, 22.09 plus the engagement or the contribution of proportional part was 4.48 here. Added to it, it gives me 27.57. And here I forget here there is 3.5, sorry, 3.5 T. So I need to substitute for here my 3.75. 3.5 multiply the time. Okay, just let me just correct the mistakes. Now after corrections, now this is the results. See, 28.23 after substituting this 0.09. Of course, if you add 7.8, it be considered as 0, which is 27.57. يعني there is a small jump for that proportional part. Now for the minute 1, effective minute 1, we substitute again in the equation. Is give me 3.5 and give me 31, and so on. Now now continue for substitution until reach to the 52 at the last limit or upper limit of the third interval. Now The fourth interval is starting from 14.8 until the infinity. It's return back to normal conditions. Now the effective time of the fourth, just 15 minus the 14.8, which is give me 0.19. Now my BV return back to the normal conditions, to the set point again. My set point is 2.36. See, so it is equal the set point here, like the first interval. Error is 0. Now my MMV return back to becomes 20, which is here MR 22.09. Now continue until the end of the whatever the time. So here just we'll take this table, we try apply it anywhere in my Excel sheet. Remember that when I will substitute here our actual time, we fill it using the fill options by the series here. Now here in this part, which is here the effective effective time, this one the actual time. Just let me make it clear, more clear. Format, now my effective time here, there is no effect, so it's still remaining as it's just normal drawings. So it will equal the same thing, actual time, because there is no effect until what? Until reach to the minutes. See here, let's see here our minute is 2.81. So to find it, we will go to see normal here to calculate. How can you find that 2.1? See here to equal. Remember that 2.81 divided by what? By 0.01, which is our here interval jumping. So we'll go to the cell number 28.1. Just go here above, in this cell. See here the selections, and we want to select here our cell, the time, actual time cell, but we want to jump to the cell number 28.1. 28.81. See how can you calculate it? 2.81, which is my limit for the lower limit of the second interval, divided by my steps, amount of steps in the time. We put it here 0.1. You remember that when you fill the series, which is here 2.81. So we'll go here 28. Now here 2.81. See that here, from here now we will start saying my effective time equal the actual time but minus 2.81. Now we'll continue to put this new actual or effective time, sorry, until we reach the limits. Our upper limits in this second interval, remember it here, 7.81. Now we'll go here again, calculate how the time required equal 7.81 divided by 0.1, 78. Just will go to 78. 7.81. Now this is my upper limit, minus 2.815 here. So we'll continue here until reach 5. This is my effective time. Now the second effective time, starting from 7.81 So my time effective here will start the actual time minus 7.8 here until I reach the upper limit. My upper limit will be 14.81. So I will try to find my upper limit locations here. 14.81 minus 0.1, it gives me 140. So I'll go here at the cell number 140. 14.81. Now this is my cell. So this one minus my 7.81, which is here 7. So all this period is considered as my third interval. Now after these times, my new effective time is starting here. So I can say 14.9 minus 14.8 till the end. Now I finished the effective time. Now we'll start substitute my no, I forget this one, just effective time here, just put it here until 2.7. now substitute for what? For our BV to draw it. We know that for this interval from 0 until 2.8, BV is 2.36 constant value until what? Until this time. Here we reach here. This is my t.36, or you can see above it 2.36. Just fill the period. Now in this time, which is 2.81, my BV changed. It becomes 4.36 until what? Until reach to the limits, upper limit here, which is here 4.36. just return back, fill it. Now the next one after the 5, remember that 2.36 plus 7, so is 9.36 till what? Till my lower upper limit of this interval, which is here, starting where? Now with this mark. Now return back to 2.36 until the end. I finished my BV. Now for our MV, which is changing with the time, for the first period until 2.1, it gives me just 2.2, just I forget the number, MR, which is 2.209. Until where? Until the effective time of the lower limit of the first interval, which is here. Now from here and so on, I will start taking the effective time plus, see the equations, 23.37, 23.37, and fill it until what? Until the upper limit for my third, for this second interval. Now we start substitute for another value here. Let's take it what? 30.5 multiply time plus 27.57. 27.57. So this is my interval. The time multiply 3.5, the effective time, of course, 27.57, 27.57 until the end of the interval. We'll go to the cell 145. Where is it? Now here. Now sorry, not this one. Let me just jump over. Where is it? I missed the point, starting point. Sorry, I forgot where I jump. Yes, here I was starting. Now it becomes 3.5 multiply the time interval here, times effective, and will continue from this period until 14.8. 14.8 here. Now after that my MR return backs to my MV. So after this one, 22.0.36, oh sorry, 0.09 until the end. Now we want draw my table. I have my MV and I have my BV. Go here, go to the insert, choose the suitable graph, which is the first one here. Now it gives me this empty one. Now I need to select the data. It show me here which one should I enter. Add the legend. We call it MV with respect to time. Press this arrow up, the return backs. Now select your values, which is here, MV. Until what? Remember that we say we will jump until 20. If you see here يا شباب, just to for your information, let's say go here, see this is the cell number 200.03. This is the limits here. So return backs to our above parts here. Click here, chart design, select data, adding the MV values starting from here until we say 203. See يا شباب, this is the resultant line. Okay, now we need to add also a new graph for my BV, what's changing with the time. Press the arrow, return backs. Now take the series. This is my PV also until 203. Now we have notes here. This is the drawings for my MV and this is the drawings for my BV. طيب, regarding my horizontal line, this one is not time, here is the cells. see the number of cells here. I want to edit the horizontal line to match the times, required times. Now go here to my edit, access a label range here until 1203. See, from 0 until the 20 minutes. Here our first period 2.8, end at 7.8, then start from 7.8 until 14.7. Then after that return back to the normal conditions. Here is 2 and here is 2.03. 2.03, but here is 4.36, but here 9.36. Now my MV, which is here MR 22.09, 22.09, but here is a linear equation. See here 26 and changing 27. Now here the slope increased up 32, 35.97. Now this is my drawings. Here my drawings, maybe it does not appear the legend here, the legend of the drawings. We can see here, put here the legend to define. The blue one is the MV and the orange one is the the orange one is the BV and the blue one is the MV. خلاص, we solve the question.